In this section, we talked about APIs and libraries. A library is a collection of classes and methods for reusability. A library may have API. API stands for Application Programming Interface and is a part of the library that is exposed to the outside. Nowadays, most of systems have their own APIs, such as LinkedIn, Twitter, YouTube, Google Maps, etc. The first example is Authorize.net API with the credit card processing example. There is a nice illustration at platpay.com. It describes the process of payment using Authorize.net. In step 1, the merchant submits the credit card transactions to Authorize.net payment gateway. The transaction can be at a retail store or a website. The payment gateway of Authorize.net now passes the transaction to the merchant bank's processor. The merchant bank's processor now submits the transaction to the credit card interchange, which is a network of financial entities that manage the processing, clearing, and settlement of transactions. In step 4, the credit card interchange routes the transaction to the customer's credit card issuer. Credit card issuers are like Amazon, like United Mileage. The credit card issuer approves or declines the transaction and then passes the transaction back. The transaction goes back through credit card interchange and then the merchant bank's processor and then the payment gateway of Authorize.net. The payment gateway of Authorize.net now stores the transaction results and send them to the customer or the merchant. And finally, the credit card interchange passes the fund for the transaction to the merchant's bank account. In order to use the Authorize.net API, you need an account, a developer account. So you go to developer.authorize.net and register for a sandbox account. When the registration is done, it sends you an email with instruction how to get the login ID and transaction key, and you will use them in your code. Here is a list of test credit card numbers that you can use to test the system. In the credit card processing example, you create a form like this. Information on the form is submitted to a test web URL. The details is in the code. So this is an example, and it is preloaded with some sample data. This is a test credit card number with the amount of $1. The expire date can be any day from now, and also the security code. When you click a submit button, so at first it say the merchant ID or parcel is invalid or the account is inactive. So you need to fill in your own login ID and transaction key to make it work. This is a part that you have to fill in your email address, the login ID, and the transaction key. So I filled in the login ID and transaction key, and now when I click submit, it says success. The next example with API is the Trader API as well as XT API. The Trader API is written by Ben Van Vliet in the introductory C++ book, namely Building Automated Trading System with an introduction to Visual C++.NET, and then I adapted the C++ code into the VB.NET code, and the code needs to add reference to Trader API.dll. This dynamic link library simulates XT API, and XT API is developed by Trading Technologies company. With XT API, you can develop custom add-on applications with electronic trading strategies. An application can receive real-time market prices and updates, submit and execute orders, receive orders, and fill information, manage orders, and etc. A trading application may need to connect to multiple APIs for different markets. So this is a picture of the market. You can buy at the market, and by default the quantity is 6. You can sell at the market, buy limit or sell limit. Now we talked about Solver Foundation API, which is a .NET based optimization platform with solvers for linear programming, mixed integer programming, quadratic programming, constraint programming, etc. Look at the application of Solver Foundation API for data envelopment analysis to compute the efficiency score, credit score, etc. As an example, several car models are evaluated for efficiency, and for simplicity, the only input is how much gas each model consumes and how far each model can go. And the efficiency is simply the output divided by the input. In general, each model is a unit, and the number of units is D. And in general, there are multiple inputs and multiple outputs. N is number of inputs and M is the number of outputs. Di is the level of input I from unit D. And in the example, it is how much gas the model or unit D consumes. And ODJ is the level of output J from unit D. The efficiency of a unit ED is the weighted sum of the input levels divided by the weighted sum of the output levels divided by the weighted sum of the input levels. So basically, this is an optimization problem. Letting the denominator to be 1. Letting the denominator be 1. You maximize the numerator. And this is a linear programming problem. This is the additive function. We maximize the weighted sum of output with several constraints. The first constraint is constraint for the denominator. The second is constraint that means the weighted sum of the output is always less than or equal to the weighted sum of the inputs. And also all the weights have to be positive or 0. In order to run this example, you need to install Founder, the server foundation, and then add reference to Microsoft.server.foundation.dll. And in your code, specify the namespaces Microsoft.server.foundation.servers and Microsoft.serverfoundation.common. Let's take the Twitter application for example. We have 5 profiles and 3 variables. The number of tweets and the number of following are the inputs, and the number of followers is output. So you run the application and look for the file. So when the application finishes, it displays a message saying done. And then you open the file and look at the score, efficiency score. It is interesting that this person has 478 followers and the other has 101 followers. But this person has a lower efficiency score than the other. The reason is the input with the number of tweets is much higher than the number of tweets of the other person. However, the width for this input is 0. And the width for the second input is much higher. ML library for machine learning and data mining purposes. This library is available at NUML.net. So you will download the library, add reference to the DLL file, and then specify the namespace. There is a number of machine learning algorithms provided by this library. The credit card approval classification example is based on the basis theorem. Given a data set with a number of attributes as well as the class label, and the class label can be approved or disapproved. Given a credit card application or test record, the probability of class given attributes is calculated. The posterior probability is calculated for each class label, and then choose the class label that maximizes the posterior probability, and that class label is assigned to the test record or the test applicant. The example application uses the human credit dataset from the University of California at Irvine website. For simplicity, only several attributes are selected, which are attribute 1, status of existing checking account, attribute 3, credit history, attribute 7, present employment since, attribute 17 job and attribute 20 foreign worker. And this is the data set with 20 attributes as well as a class label. Most attributes are discretized. So let's assume that we are running the credit card check for an applicant. The application turns out to be approved. But what if we change job to unemployed and foreigner to yes? Then it is disapproved.